Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at monitoring a folder while we await the creation of a file. Today's video has been suggested by one of our subscribers. In this application, we're going to be doing the task of monitoring for a file appearing inside a folder. Let's say one of our users is going to prepare a file. And this file is going to be deposited in this target folder. At the moment, the target folder is empty. And our application is going to have to monitor this target folder until such times as a specific file is deposited in that folder. Our application can then begin processing it. So let's look at how we would actually perform this task. We're going to set up three local variables. One to contain the name of the file that we're looking for, a second variable to contain the path and the name of the folder we are interested in, and the third variable will contain both of these previous variables. So we have a file name variable which is going to contain the name of the file we're going to be looking for, which is targetfile.txt. The folder variable is going to contain the path which our executable currently sits in and the subfolder called target folder. And our file name path variable is going to contain the folder name plus the name of the file we're looking for. And we're going to create a new function whose job it will be to check for that specific file in that path. So we're going to create a new function called check_for_specific_file, taking a single parameter. So what we'll do first of all is we'll put a message out to our log to say what file and what path we're actually looking for. As we have no idea when our user is going to deposit this file into the folder, we're going to have to run in a loop. So the easiest way for testing to see whether a file exists or not is to use the inbuilt function isFile. This inbuilt function will return either a true or a false. So we're testing here to see if it's true that the file does exist. And if so, we'll put a message to log to say we've actually found our file. And assuming that we have found a file, we can for the moment exit our loop. Now while this particular function is currently functional, it does have a major issue. So let's try running our application to see how it performs. Now that's our application running, but at the moment the target folder is empty. So the program is running in a loop. As you can see from the display of the CPU usage, one of our CPUs is running at 100% load. So while the application is running, it's very heavy on the computer. Can we make it more efficient? Before we try to do that, let's copy in the target file the program is looking for. If we paste this into place, we'll find that the program acknowledges it has indeed found the file and the program has now completed. And the percentage CPU usage has dropped back to 0. So although our program is actually functional, it's not very performant. So how can we improve on this? The problem at the moment is that the testing for the file, the testing using the isFile function, is running around a very tight loop. There is absolutely no delay, and the computer will be testing for the file every few milliseconds. What we need to do is to put a delay in here. Well, we want to know when the file appears, we don't have to know it right down to the nearest millisecond. Checking every second or every 10 seconds would probably do quite nicely. So before the loop command, we're going to put a sleep command in. I've put in a sleep command of 1000 milliseconds, so that having tested for the file, it will then wait a full second before testing again. So let's try running the application again, but first we will remove our file. And there is our application running. Now, as you will see from what's on screen, the percentage CPU is nowhere near as high as it was before. It's barely noticeable. So let's copy the file in to see if it will still detect it. and there is our file having been found. So a simple delay of 1 second is enough to make the program much more performant. When you're waiting for a user to deposit a file into a folder, you don't need to check all the time. Checking once a second or once every 10 seconds or perhaps even once a minute would do nicely. So now that we have the computer performant, what else can we do when searching for our file? At the moment we're searching for a specific file name. Again, we don't know when this file is going to be deposited into the folder. There's always a possibility the file could be deposited several times a day, and you would want to pick it up whenever the file's copied in. But since we're running in a loop here, currently once a second, if we start processing our file, 10 seconds later after we've finished processing the file, we would detect that the file is there again. So we need a mechanism by which we know that we've already dealt with the file. If the file is always going to be the same name, you can't depend on the file name. So is there another way of actually knowing that we have seen this file before? To do this, we would need to look at the content of the file. At the moment, our target file has only one line of data in it, of the numbers between 1 and 6. So we know what the content of the file actually is. So what we're going to do is to borrow some code from a previous video. We're going to copy in some libraries. We're going to copy in the file handling routines library, and we're going to copy in the file hashing libraries. What we're going to do is, every time we need to look at the file, we will generate a file hash. And we will want to compare that against the list of file hashes we have already dealt with. So we want to store any file hash that we've already dealt with in a hash file. So we will create a constant to contain the name of that file. So this is going to be our hash file to contain all these file hashes. So in here, once we've detected that there is actually a file there that we're looking for, we'll want to call a new function. A function to determine to see whether we've processed the file already or not. And only if that function returns false will we continue processing. If this function returns true, it means we've already processed this file. So we'll then put a message out to log to say we're now starting processing. And at the end, we want to actually add the hash value to our hash file. So the process to determine whether the file has already been processed or not is going to take 3 parameters. 1 input parameter and 2 output parameters. The input parameter is the path and name to the file we wish to check. The 2 output parameters are first of all an error variable and secondly the file hash itself. This processed file already is a function we created in a previous video, but I'll go over this one again. This is the skeleton of our new function with the 3 parameters in place. We're going to create some local variables. So we have one variable to contain the file hash. We have an array to contain a list of all the hashes we have already processed, and an index. So first of all, we're going to call one of the functions in the libraries we just added to generate a hash number for the file itself. So should that getSHA function return unable to hash, it means it was unable to hash the file. And we will return the error message back to the calling function. Next we have to check to see whether the hash number is already in our hash file. So we can use one of the functions in our PB file handling routines library to determine that quite easily by loading the file into an array. If this file does not yet exist, it means we have not calculated any hash numbers yet. So we can return a false, as this file has not been seen. And we will populate the file hash variable to return to the calling routine. So to determine whether this hash number has been seen already or not, we're going to use the array scan command. It will quite easily scan through our array to look for matches, and should it find a match, it will return the element number in the long index variable. So if that returns a number greater than 0, then we have actually found the hash number. Therefore the function will return true to say we have already seen this hash number. So that should complete our processed file already. So having called the processed file already, it will return true or false. If it returns false, then we have not seen the file before. We can print out processing and we can append to the hash file. So the newly generated hash will be added to the end of the list. And from a design point of view, we need to decide whether we wish to exit the loop at that point. If we want to continually monitor for these files appearing in, we can remove the exit loop. If we want to exit after having processed a single file, then you can leave the exit loop in. So if process file already returns true, then we have seen this file before, so we need to do nothing and continue looking. So we try a quick compile on that, and our application compiles quite cleanly. If we remove that file for the moment, and run our application. Now our application is running quite happily, and we can also see that the processes are not overloaded. So if we next copy our file in, it should pick up the fact we've got the file. Which it does. The second file not found message is because it didn't find the file hashing file. If we go back to the root of our folder, we'll see we now have a file hash record.txt file. And this has in it the hash number of our file. So if we run our application again, and we leave the target file in position, so the file is actually there. If we run the executable, it's continually running round the loop, checking for the file hash. Because the file hash being returned is exactly the same, it knows it has seen that file before. However, if we open the file up, and we make a minor change to the file, and save it, we will see that it's now given us a message to say press any key to exit, so it has actually found the file. And if we look inside our file hash record, we'll see there are now 2 records in there. It has identified that the file has been changed and can be processed. So we now have a method of actually monitoring a folder continually, waiting for a specific file to be copied into that folder. We can then check the content of that file to see whether it's a file we have seen before or not. If the file has been seen before, then we will continue waiting for another file to come in. If we haven't seen the file before, then we can continue and do any processing you wish on the file. Hopefully you'll find this mechanism for monitoring for files in your folders useful in your applications. But that's it for today. Thank you for watching.